We're moving on to the Hardy-Weinberg equation. The equation is based upon the Hardy-Weinberg equilibrium that states that the genetic variation in a population with random mating will remain constant over its generations unless there are evolutionary forces acting on them. The Hardy-Weinberg equilibrium predicts that both the genotype and allele frequencies remain constant because they are said to be in equilibrium. These factors that disrupt the equilibrium could include natural selection, mutation, genetic drift, gene flow, or non-random mating. All of these factors regularly occur in nature, so the Hardy-Weinberg equilibrium doesn't apply in reality and describes an ideal scenario, and is used as a baseline to determine the extent of evolutionary forces acting on a population. So let's start with an example to go over the equation itself. Here are three poodles of the same species with a slight difference of pink and black fur colors. All poodles in this population's genotypes will either be Big B, Big B, Big B, Little b, or Little b, Little b. Our allele frequency will be 70%, or a frequency of 0.7 alleles are Big B, and 30%, or a frequency of 0.3 of the alleles are Little b. First, let's note that there are two equations, p plus q equals 1, and p squared plus 2pq plus q squared equals 1. The first equation is for allele frequencies, which we know and is easy to calculate. P stands for the dominant allele B, and Q stands for the recessive allele, little b. 0.7 plus 0.3 is equal to 1. The second equation does look scary, I know. Trust me, it was scary to me as well until I learned how easy it is to calculate. This equation will result in the predicted frequencies of all three genotypes. P squared is for our homozygous dominant genotypes, 2pq is for our heterozygous genotypes, and q squared is for our homozygous recessive genotypes. We will plug in our values from our example that we used in our other equation. This gives us the predicted genotype frequencies for our poodle population. Once you know your values for P and Q, the equations are quite easy to calculate. Now that we know how to calculate the Hardy-Weinberg equation, we're moving on to our next topic of learning. Let's go!
Created using Powtoon.